Now we're looking at a variety of tubing connectors. These are polycarbonate connectors used to connect one piece of tubing to another piece of tubing. The nomenclature around connectors are that these are all straight connectors. They just go straight through. And the rest of the nomenclature is based on the size of each end. So this is a half-half straight connector. 3/8 3/8 straight, quarter straight, 3/16 3/16 straight. Maybe even shorten that up to this is a 3/8 straight connector. These straight connectors may have luers associated with them. Here's a half-half with a lure. Here's a 3/8 straight with a lure, quarter with a lure. There are also connectors that change the size of tubing. So you connect a 1/2 inch piece of tubing to a 3/8 inch piece of tubing. These may be called reducers or enlargers. So as in, hey, run to the pump room and get me a 3/8 quarter reducer. Those reducers may also have luers on them. Let's take a look at the anatomy of connectors. All these connectors have what we call barbs on them. Here's a barb, the first one, and this is the second barb. The barb is your target, your minimum target when you're advancing tubing on the line. When you make that tubing connection, you want to make sure that you get this end of the tubing at least past that second barb. If you can sink it all the way up to the top, that's even better. But it's not a well-seated connection if it didn't get it past the second barb. The barbs are also the target for your tie bands. You'll place that tie band around the tubing so that it sits between the first barb and the second barb. Just like that. Then you would snap that off. In addition to straight connectors, there are also Y connectors. Y connectors provide 3 points of connection. Here's an example of a half, or a 1/2 inch Y. Here's a 3/8 inch Y, which is 3/8 3/8 3/8. Here's a 1/4 inch Y, quarter. These Y connectors may also have luers on them, and they may also be reducers or enlargers. Here's a 3/8 3/8 1/4 Y with a lure. This is a 1/2 3/8 3/8 Y with a lure. Here's a 1/2 3/8. Sometimes they have funny shapes. This one looks kind of like a straight connector with a branch off the side of it. This is a 1/2 1/4. Fairly uncommon connector. Here's a 1/4 3/8 3/8. The anatomy of these connectors is very similar to the straights. They also have 2 barbs for holding the tubing on the connectors and a point of attachment for your tie band. Now let's take a look at some of the caps that you find on tubing. Here's 3 different sizes of tubing, 1/2, 3/8, and 1/4, and they all have caps on them. That's better. Many clinicians would agree that if you take the cap off this piece of tubing, that the cap is still sterile on the inside. And the tubing, since we're not going to touch any of that, sterile on the outside and the inside. So we could take the cap off, and you could put the cap back on. That's okay. You could take this cap off, and you could be really careful with it. Maybe cut this tubing. Maybe put a connector in or something. At the end, you can put this cap back on. That's okay. But you should not take this cap off and put it in your palm, or drop it on the counter, or put it in a bucket on the side of the pump, and then pick that cap back up and put it back on. That cap's probably not clean enough to go back on the tubing. So tubing caps are used to keep the ends of tubing clean. Are all of these caps here tubing caps? Kind of a trick question. Some of them are connector caps, and the connector caps look very similar to the tubing caps. These three right here are designed to fit on connectors, which means they're smaller. So here's a 3/8 inch connector cap. I'm sorry, it's a 1/2 inch connector cap. And here's a 1/2 inch connector, and it fits on really well, and it stays on. If we try to put that same connector cap onto the tubing, you see it doesn't really fit. Maybe you could force it on, but it's clearly not designed for that. Similarly, if you were to try and put that tubing cap on this 1/2 inch connector, it doesn't stay on. It's way too loose. So you might notice if you're trying to use these caps for other purposes that sometimes they fit and sometimes they don't. That's because you actually have connector caps. Here's a 1/2 inch. Here's a 1/4 inch. The 1/4 inch connector fits really well. Does not fit on the 1/4 inch tubing. So these two are connector caps. And get them off the table. One of the things that these caps are useful for is if you're going to make a sterile connection to a connector. And say, for instance, your connector comes with two uncapped ends. One of the ways to manage this is to use the cap off the end of your tubing to cover the end of your connector. So let's open this up. Pick our connector up. Don't touch the ends. Take the tubing. Put the cap on it. Put all that in your hand and make your connection. I'm going to leave it loose. Remember, it's a tubing cap. You put it on a connector, it's really loose, it'll fall off. So it's not a final solution. You need to tape that on or take that off and finish your connection with another piece of tubing. By the way, as long as we're talking about this, another way to help make these connections is to use the packaging that the connector came in. For instance, if we were just opening this connector, this wrapper is sterile too. You should stay away from the stuff that was glued down, but that stuff in the middle, that's good and sterile. So what if we peel that off completely? Put the connector right in the center. Now I can put that in my hand and make my connection. Also, not a permanent solution. That's going to come off, so I better have a plan for what to do with that end after I take it out of my palm. Another way to make those connections is even easier if it comes in a bag. Here's a 3/8 quarter. So let's grab a piece of 3/8 inch tubing. And if we open this bag with a 3/8 inch pointing out, we just fold the bag down, exposing only the end that we need at the moment. And make this connection. Not a permanent solution. You should have your plan for what you're going to do with that other side. Let's now consider the gender of extracorporeal connections. Here I have two caps. One of them is called male, and the other one would be called a female cap. Can you tell which one is which? This is the male cap. The male cap has a protruding end that fits inside the female cap. And they're designed to lure together, so you twist them and then they lock closed. We have a variety of male caps here. This lane of male caps are caps specifically designed for certain oxygenators. They have a exceptionally long end that fits down into a connector, filling the entire lumen of the connector, so that no blood can accumulate or clot. This one is extra large for larger than normal size lure connections. All of these caps are pretty standard, but there's two different kinds of caps. These two rows are standard non-vented caps. This row is vented caps. If you look real closely at them, you'll see there's a hole that goes all the way through. If you are placing a cap on something that you need to not leak, you want to be sure you're not using any vented caps. There are a variety of other connectors which will provide a lured connection. Here is a quarter to male connector that will allow you to convert a piece of 1/4-inch tubing to a male connection, which could then be put on any standard lure connection and would fit any standard female cap. This is another version of the same thing. 1/4-inch to male lure fits a standard female cap. This is a connector that is a rotating male, so that could be placed and help you connect two female lure connections. Not a lot of application to connect two caps, but if this were a female piece of tubing and this is a female piece of tubing, you needed to extend them, connect them together, you can use a male-male connector. Now let's take a look at some of the connectors and caps you'll find on the top of a cardiotomy reservoir. The cardiotomy reservoir is the container that we drain our venous blood into. It's a bucket with some filters and a bunch of caps and connections on top. We often need to seal this container so that we can generate a negative pressure on the inside. To do that, you would have to make sure that all of the ports on top are closed. When the cardiotomy reservoir comes out of the package, it will be completely capped up. As you see here, every connector is covered. And some of these connectors, they know you're going to remove and throw away so that you can use the cardiotomy. So for instance, here's the cap that goes over the venous line. If you look closely at that cap, it's got some grooves on the sides. This would be a non-sealing cap. This cap cannot be put on so tight as to completely seal that connector. Gas, air will always be able to get in and out underneath that connector. Other caps that are on here, they don't know if you're going to remove or not, so they have prepared them to be sealing caps. If you look at this one, it's completely smooth on the inside. It fits tightly around this 3/8-inch connector. And if you were to apply a vacuum on this, it'll be sucked tight and this cap will be sealed. These lure caps that are on the top, in this case, they are non-vented. And these blue caps on the sides are also caps that can be sealed. If you leave these in place and apply negative vacuum, negative pressure to the inside of that cardiotomy, these caps will be pulled tight and it'll be sealed off. All of these sealed cardiotomies will have some other port that they'll recommend that you keep open. So if you read this one really closely, it says do not obstruct, and it has the word vent right here. That cap that goes on that is obviously a vented cap. It has huge wings on the side to make sure that this can stay in place to keep this port from becoming contaminated. At the same time, air can freely get in and out underneath that cap. This differentiation between sealed and non-sealed caps is very important for your cardiotomy reservoirs. Here are several other lured caps that you might have in the course of your day. And if you had saved some of these and then later on decide you want to cap something up on your cardiotomy and you made a substitution with this vented cap, you'll no longer be able to see this seal this cardiotomy reservoir. Similarly, other oxygenators have caps. Here's some 3/8 inch caps for the top of a cardiotomy. Not this product, but another product. And they could fit on top of this 3/8 inch port very nicely and keep that port nice and clean. But because of the grooves on the inside, it won't seal that connector, and you'll not be able to draw a vacuum inside this cardiotomy. So as we move on to some more advanced techniques such as vacuum-assisted venous drainage, you really need to be able to troubleshoot the caps that are on the top of your cardiotomy reservoir to determine why you may or may not be able to achieve the vacuum you think you should. Another very commonly used connector is a stopcock. There are a variety of different kinds of stopcocks. Here's a standard 3-way stopcock. Has a male on this end, 2 females, and it's got a rotating valve. There's a hole that goes through the center of this valve and a hole off this side of it, but there's no hole off this side of it, so it is off in this direction. Flow can go through here, not out there, until you turn it. Now flow can go here, but not over there. It's off to this female port. That's a 3-way stopcock. This is a 2-way stopcock. There's a male and a female, 1 rotating valve. It's off. It's on. Stopcocks may come all ganged together. We would call that a manifold. Manifold, the stopcocks on the manifold work the same way. Off to this one, on straight through, off to this, straight through the whole manifold is open now. Some stopcocks, instead of telling you what's off, the arrows tell you what's on. Here it is in a 3-way manifold. This stopcock has an arrow pointing that way, and that way. No arrow pointing this way. This one's off. These 3 are on. Now you can have flow straight through here. It will not leak out there, but it will leak out there and there. Come in a variety of different colors. Some have rotating ends on them. Others do not. To lower this in, you have to turn the entire stopcock. To lower this in, you can hold the stopcock firm and turn the rotating collar. These stopcocks have more than 3 positions: off to the male side, off to the female side, off to the other female side. They can also open all ways. This would be an example, just open, 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 off to nothing. So the entire thing is open. And you can also turn them off at 45 degrees. Since the hole is in this line and this line, if you turn it off in between these ports at 45 degrees, then it's off, off, off to everything. Here's an example of some quarter straight connectors that have a very special application. These devices are called a vacuum relief valve. They can be placed inside quarter-inch tubing, quarter, and what they do is provide a one-way valve. So you can see the valve inside this connector points in this direction. So flow can go through the valve this way, flow cannot go through the valve that way. So if you put this in your quarter-inch line, you cannot pump in that direction, but you can pump in that direction. The second thing they do is reduce the amount of vacuum that can be generated inside that quarter-inch tubing. So if you have a roller head on this side drawing through this pump, and you run out of volume on this side, the roller head will not be able to generate an excessive negative pressure on this side, because the other valves up here will allow air to come in and go through the valve. These VRVs, or vacuum relief valves, may limit the amount of vacuum that can be generated on this side of the connector to about -50 to -75 millimeters of mercury. You'll be responsible for being able to identify these as vacuum relief valves and knowing the direction of flow. The clear ones, it's pretty easy. You look at the connector and you see which direction the valve is pointing. If they're not clear, then you have to read them. Also pretty easy. This one says the direction of the pump is on this side. So this valve and this valve are in the same orientation now. Pump over here, heart over there, heart over there. Another kind of connector you will run into is called a Hanson fitting. The Hanson fittings go on the end of your water lines. It's a 1/2-inch push-in fitting to this industrial strength locking and you can put it on and take it off industrial strength connector. Oftentimes the 1/2-inch tubing is something more aggressive than normal PVC. This one is fiber reinforced and held on with a plumbing style tubing connector. They can have a right angle or they can be straight. They have a collar. You pull the collar back. When you pull the collar back, it releases the tension on these bearings, which then fits onto the connector of your water lines for your oxygenator. Let me show you how that works. Here's an oxygenator. These are the water lines. Probably come out of the package with a cap on them, maybe a white one. Hanson fitting. It's going to interface with that groove right there. Pull the collar back. Push the connector on until it clicks. And it can be taken off by pulling the collar off